Alright, yeah, so continuation of the last problem we were doing. So this one here, calculate and interpret the 45th percentile of the runner's body weight distribution. So here, excuse me, I'm dealing with a percent. Okay, so 45th percentile. This is what's different about this one. I started with a percent, and I want to find an actual value. So I'm still going to use this equation, the one I've been using, but now I want this x value. That's really what I'm looking for. Okay, and so calculate and interpret the 45th percentile. Well, remember, this mean right here would be 50%. So 45 would be somewhere over here. So what I'm looking for is this right here. So when I start with a 45%, I think, again, I'm going to use the calculator, so I'm going to show you how to do that here. When I'm starting with a percent, let's go ahead and deal with the percent. So 6, menu, stats 6, and then again, distributions, which is 5. And now I'm doing the inverse normal. Okay, so here the area that I'm talking about is the percent that I've been given, so 0.45. So the z-score that I'm talking about is negative 0.12, which should make sense because it's pretty close to the 50%. So z is equal to negative 0.1257. Okay. So if I want to know the value of x, well then I'm going to go ahead and set this equal to x minus x bar over standard deviation. So negative 0.1257 equals x minus 63.1 over standard deviation of 4.8. Okay, so here, guys, I can go ahead and just push in solve. So menu 3.1, y'all are pretty good at that already. So the value of x should be 62.49. Now, well, 49, I guess I can say 50. So, again, if you just say this is not going to be the correct answer. This is the threshold point of what this number should be. Okay, and so if I want to deal with the 45th percentile, remember, that means that everybody below him is part of that number. So I'm asking for when is the x less than 62.5. So the proportion, well, let me see, the 45th percentile represents the approximate number of runners' body weight that is 62.5 kilograms or less. Okay, so I like this question because it goes over everything pretty much. And so, again, let's deal with this here. So now, find the proportion of observations from a standard normal distribution that satisfies this right here. Okay? So sketch the normal curve and shade the area for which I'm dealing with. So again, guys, here they gave me some z-scores. So negative 1.5 would be, I'm just saying it's over here. And positive 84 would be somewhere over here. So the area I'm talking about is this one right here. Okay, so again, guys, these tables are made so that I usually find all of this area. So since I have two z-scores, I'm going to go ahead and plug them in. Oh, see, I don't need to do this. I'm sorry. I'm going to find my proportion, so from here to there. So I'll go to menu, 6, 5, and then normal CDF. Oops, I pushed the wrong one. Sorry. So again, lower bound is okay. Upper bound here I would do now is 0.84. Okay, and so this is equal to 0.7995, and the lower z-score would be negative 1.51. And so I'm going to do the same thing and find the value for the lower z-score. And now all I have to do is subtract the two. So the proportions of z-scores between these two numbers is equal to these two minus each other. So let's go ahead and subtract them. 0.734. So again, full credit, the proportion of runners whose body weight fall within negative 0.151 and 0.84, again standard deviations, because z-scores are standard deviations. Of the mean is 0.734. I guess I should say approximately. Okay, so, and the last one here, what z-score in the normal distribution has 33% of all scores above it. So again, guys, we're going to start by drawing this thing out. Remember, 33% of all scores above it. Has 33% of all scores above it. Okay, yeah, so all scores above it, so it's telling me I want this shade right here. So, again, guys, this is what's a little bit tricky about this one. The way your z-score tables are made, so this is from over here to over here. Again, this is the area I'm talking about. So, the proportion I'm talking about is 1 minus 33%. So 0.33 instead, which is 0.77. So I would do the inverse value here. So 6, 5, inverse normal. So the z-score that's associated with that, is 0.7388. Okay, so the z-score value that has 33% of all scores above it is approximately 0.7388. Okay, so last problem here, and again, this will be the last one that I deal with. So ask me your questions tomorrow. We have a little bit of time where you can clarify things, come during third period if you need to as well. So this is what we talked about today, the normal probability plot. So if I were to draw a line here, this to me does actually look like it is pretty linear. Okay, so I would say here, because here it's asking, is it approximately normal? And so due to the linearity, apparent, I should say, linearity of the data, the distribution could be the distribution would appear to act normally. Okay, so we're not distinctively saying it is a normal distribution, although it does look like it could be. Okay, so this is the free response, at least the ones that I gave you for the review. I won't do any videos for the multiple choice, so ask me your questions on those tomorrow. However, let's go ahead and just leave it right there. And again, guys, just anything else I could have asked here is, they said there was 30 pieces of cheese, so 30 samples. If I asked, if I had said that, is it a proper guess if I said 35% of the samples 35% of the samples had a mean, excuse me, of 1.4 or less. Well, I would have looked over here. So this looks like it's a 1.4, so I'm not going to count that. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of the 30 samples is 30%. I guess it's kind of accurate, so you know, maybe something on the test wouldn't be so obvious, but here this is fairly accurate, so I could say, okay, yeah, that sounds about right. Okay, so again, guys, go ahead and ask me your questions tomorrow. These will be on the classroom and also on YouTube.